Hi guys, in this video on solving quadratics, we're going to talk about completing the square. This video shouldn't take too long, but we're going to talk about what completing the square is and why it's important to know. So let's get started. First, I'm going to factor this problem. And in doing so, I need to set this equal to 0. Just like before, x squared minus 2x minus 8 equals 0. Okay, now what I have to do is I have to find my factors of 8, which I'm going to count up. If you need a review on how to factor, you can check out my video on that or the millions of videos on factoring on the YouTube. So I am just going through the factoring process. And in fact, I'm kind of handling it while talking to you guys, working towards a solution here. So now what's going to happen is I know that this parabola, which is what a quadratic forms, will cross the x-axis at +4 and -2 on the x-axis. Okay. Factoring is technically a shortcut to completing the square. So let's take a look at the process of completing the square. So now I'm going to set this up. And in completing the square, we actually do not need to set the equation equal to 0. What I need to do is actually create a space. And then on the other side, I need to create a space. The process of completing the square requires me to take the b term, which is what -2 is, divided by 2, then square it. That's the actual process of completing the square, and I will explain what that means in 1 second. So that means I'm going to add +1 and +1 here. Just a side note, what I have created is a square quadratic. So in other words, this is considered a perfect square because when I factor it, the factors are the same, or can be written like this. That's what completing the square does. It aids us in solving quadratics, and it works every single time. Now, back to the process of completing the square. Now that I've created my perfect square quadratic on the one side, I can start the process of solving for x. But the way I have to do that is I have to factor this side here. So I'm going to do that. You've already watched me do it. So this becomes x minus 1 x minus 1 equals 9. And all I did was I factored x squared minus 2x plus 1. Now for the next step. So I can rewrite this x minus 1 squared equals 9. And now I just solve for x like it's a normal equation. I undo the square by square rooting both sides. And what that gives me on this side is plus or minus 3. Now, a couple of things to understand about square roots. Square roots give us a positive and a negative. So let me create another side note. So if I were to go back to 9, let's take a look at 9. 9 could be one of two numbers. It could be 3 squared, or it can be -3 squared. Both are possible. This is not taught too often, but typically we go with what's called the absolute value of a square root. And that kind of would, I guess, look like this, which would give us 3. But if I were to take away the square roots, that means that the answer can go in two ways. It could be a positive or a negative that will get me to the square root of 9. That is where the plus or minus comes from on the quadratic formula. All right, let's finish up this problem. So now when I add the 1 to both sides to create 0 on this side, I end up in a situation. I end up with x equal to 1 plus 3 and x equal to 1 minus 3. And when I get those answers, I get 4, then negative 2, which is the same solutions I had prior. So the question you should be asking is, why would I do this over factoring? And the answer is, once again, you would not. This is the same answer of why would you use the quadratic formula over factoring? And the answer is you wouldn't. Factoring is essentially a shortcut for solving quadratics in a perfect world. So we learned to do that so we can maneuver through quadratics more efficiently. You can always use the quadratic formula or completing the square in lieu of factoring, but the real answer or question that results in that is, why would you do that? That's a waste of time when you could just factor. So now let's take a look at another example where the equation is not factorable. So in this case, we're going to start with the quadratic formula. I've covered the quadratic formula in length. Again, if you need a review on the quadratic formula, you are always welcome to go watch my video on the quadratic formula or the millions of videos out there on the YouTube on the formula. So I am quickly just kind of plugging this in, trying to hammer this out for the sake of your time. So I have 16 plus, let's see, b is negative 16 squared, 4, 1, then 62 over 2 times 1, which gives me 2, 16 plus or minus, and I believe I get the square root of 8, which simplifies to the square root of plus or minus 2 square root 2, then over 2. Then I can simplify this to 8 plus or minus. I'll put the 1 here, I guess, but I think it's going to disappear when I do the completing the square. 8 plus or minus 1 square root 2 over 1. Or, if I really want to write this the right way, 8 plus or minus square root 2. Okay, so my point is, that's the quadratic formula. Now, let's take a look at the process through completing the square. Now, when completing the square, we go in the opposite direction. So I'm going to subtract the 66 this way. And what's going to happen is I'm going to give myself a lot of room here. I'm going to get x squared minus 16x, leave myself a space, equals negative 62. Okay, and then I'm going to leave myself another space there. Just like before, I'm going to take the b term and divide that by 2 and square it. And that's going to give me 64. Because, well, positive 64. Let me make that clear. These squares are always positive. So, what happened is negative 16 divided by 2 is negative 8. Negative 8 squared is positive 64. And now I have to add that to both sides, just like I did before. I have now created that positive perfect square situation, so I'm going to factor that. So I'll rewrite it just for clarity, but I have to factor this x squared minus 16x plus 64. And the question is what multiplies to 64 and adds to 16? Negative 16. You actually saw the answer already right here, which is negative 8. So x minus 8 equals 2. Now I'm going to rewrite this. X minus 8 squared equals 2. Okay, Now I'm going to go through the steps I did before, which is to square root both sides. So that goes off and that goes off there. Okay, a couple things I want to talk about here. So the square root of 2 does not reduce, but the plus or minus still goes in front of it. So that plus or minus is kind of one of those unwritten things that are in front of a square root. There's a little bit of nuance here to where all this stuff is coming from. Okay, now I just got to add the 8. So I add the 8 to both sides, and I get x equals 8 plus or minus square root of 2, which is the same answer I got before with the quadratic formula. But, if you ask me, a whole lot more efficiently. Okay, so a couple things I want to point out. The quadratic formula comes from completing the square. It's actually derived from that. There's piles of videos on it on the YouTube out there in the universe, so I am not going to create one. Where does this become inefficient? I guess my answer would be is if I had decimals, then it kind of gets a little sketchy. But, in other words, I guess what I'm trying to say here is I'm tripping over my words, is that if I had decimals in these equations, is it faster to do this with the quadratic formula or completing the square? And the answer is they're both about the same. But when you have this kind of situation here, which are nice clean numbers, you can definitely use completing the square a whole lot quicker than you can using the quadratic formula. There's another factor before I leave us, and that is that the completing the square gets used in advanced maths a whole lot more than the quadratic formula. Quadratics by nature are a pillar of math because they are very physical. I spoke about this in a previous video. And they become apparent in a lot of maths, and oftentimes the way we get through them is we have to complete the square. So, that is 2 examples on completing the square. I hope you guys found this video helpful.